Hi, my name is Andrea Pittman. Welcome to the Pediatric Amplification Lab. This is our lab where we test children and adults with hearing loss, mostly children, and our children are between the ages of about 8 and 12. In the Pediatric Amplification Lab, we study the behavior of children and how they interact with the behavior of hearing aids. And the goal is to find the right hearing aid features that allow children to do what children need to be able to do. So in this study, we examined the effects of fast, slow, and adaptive compression on the ability of children and adults with hearing loss to perform complex tasks. And we asked them to do an auditory task and a visual task at the same time because we wanted to simulate something that would be in a dynamic environment like a classroom. And then we processed our auditory scenes so that they were consistent with fast compression, slow compression, and then the characteristics of adaptive compression. And then we wanted the listeners to listen for a target stimulus that was embedded in these auditory scenes, and that target could have been words or environmental sounds, and then respond to what they heard.
Let me do that one again.
Oh, a doorbell.
A doorbell, yeah.
Animal. Food. I don't know.
And what we found was that the listeners, both the children and adults with hearing loss, performed fairly poorly, actually equally poorly, with fast and slow compression. And we think that what happened there is that the fast compression distorted the signal a bit by decreasing the signal-to-noise ratio. It was simply noisy. And so you'll hear this as a little bit louder and a little bit noisier.
Lifeguard.
And then the slow compression was a poor signal due to underamplification.
Lifeguard.
Because the slow compression wasn't able to restore the amplification in time for the listeners to detect the sound that was embedded in the auditory scene. When it's processed with adaptive compression, what you'll hear is a clearer signal for the portion that is not being masked by the environmental sound.
Lifeguard.
Both the children and the adults with hearing loss, their performance improved significantly with an adaptive compression system, we believe, because that system allowed them to access the signal embedded in that auditory scene better than both fast and slow compression. So these results suggest to us that in systems like the SpeechGuard E that have an adaptive compression that takes the best of both fast and slow compression parameters and combines it into one system, that those children and adults in dynamic listening environments are likely to benefit greatly from that kind of an amplification system. Some companies like Oticon do that very nicely, and they get it, they understand kids. But there is this gap between what children with normal hearing kids can do and what the children with hearing loss can do. So my ultimate goal would be to close that gap. Well, anyone interested in learning more about the details of this study can read the published article in the Journal of the American Academy of Audiology.